Good day. We are the VIVA Senior Design Team. Today we're going to present Design Review 2 of the Wireless Audio Distribution System, our Senior Design Project. And I'm Addis Elliott.
I'm Jordan Coles.
I'm Gideon Jones. And I'm Christian Ford.
So the motivation behind our Senior Design Project is to solve the problem of a loud ruckus in a sports bar and allow all customers as well as patrons that are coming into the sports bar to be able to listen to the entertainment of their choice. And with this said, we develop a project that uses wireless technology, to incorporate wireless technology and able to solve this problem for the ruckus, so the people that come into the sports bar will be able to select the variety of their entertainment as well as still be able to socialize as what a sports bar is for.
So we're going to go over our background problem analysis, as well as the requirement specification, level 0, 2, 3 blocks, diagram, UML diagram, test document, the work breakdown chart, the Gantt chart, the cost summary table, and the expected student competition.
So to go even further into the background and problem analysis, where we see this problem existing is in social gathering venue areas such as sports bars. Why we see this as a problem is right now there are social gatherings, and they have a bunch of TVs right now, and it can become hard to hear audio from one TV or another once you have multiple TVs playing at the same time. So that's really the main reason we want to tackle this problem. So the way we go about solving this solution is to create a completely wireless system that will allow for audio from two separate sources to be broadcasted. The aim is to implement this distribution system that will exist between multiple sources of audio and two endpoints, different user endpoints. And the overall goal of the system is to design a system that will allow for 10 people to listen to each audio stream simultaneously. So to go over our requirement specification based on our engineering requirements, the four marketing requirements that we have: our system must be user-friendly, interoperable with the existing market, manageable, and produce quality audio. The application must allow for the user of application to understand the capabilities in 5 minutes. We feel like this engineering requirement ties in with the market requirement of being user-friendly, because if it takes, first of all, this is a system that's going into the sports bar, so you don't want this to be the main focus of your event, is trying to hook up this device. So if it takes more than 5 minutes, it starts becoming a burden to the user and no longer friendly. The second engineering requirement is the system must have a setup time of less than 7 minutes. This one also kind of goes into more detail from the first one and plays off the user-friendly, because now once you understand its full capabilities, you want to be able to set it up in a time of 7 minutes. We chose 7 minutes as an arbitrary time, not too much and just not too few, saying like 5 minutes. The second marketing requirement of being interoperable, two engineering requirements that we created based off of this were that the system must be compatible with at least 2 different types of Bluetooth speaker types or brands, and the system must work with any Android or wireless speaker. Both of those we felt were important, because if you can't fully integrate the system we're making in the existing market, again, it becomes a burden to the user and it loses a lot of its value, because we're trying to solve a problem, not create more. For the third set of engineering requirements, the total system minus the end-user devices such as the phone and speaker should be able to fit in a briefcase bag. And we felt that this was something of value, because you don't want to have something, a large system sitting on your desk, on your table while you're eating, or if it's something that's decided to be mobile. You don't want to have to carry a whole bunch of equipment around. And the second one, off the third marketing requirement, is the total hardware system must weigh less than 3 pounds, which is a manageable weight that you can easily carry and it won't be a burden to you. And for the last set of engineering requirements based off of the system must produce quality audio, first one is the output of the speakers should not receive distortion within 15 feet. We chose 15 feet because we felt that was the standard range of Bluetooth, and it was just a range where you shouldn't expect to hear a loss in quality of your audio that you're hearing. And the final engineering requirement that we had was that we want our audio system from input to output to receive, to have the largest signal to noise and distortion ratio possible. the reason we wanted to choose signal to noise and distortion was because it is measured based on the frequency coming in and the input coming in versus the output. And so upon further research and knowing exactly how the signal to noise and distortion ratio is determined, we will be able to pinpoint an exact specific number to determine whether it passes or fails and produces quality audio.
That last one is very agree with what you're saying. You're saying it should have must have a larger signal to noise and distortion ratio. What does that mean? Larger than what?
So, like I was saying, as once we do more research on the optimum signal to noise ratio and pretty much the limits of signal to noise ratio, where it says, okay, once you're past this ratio, you're no longer producing quality audio. Once we do more research to pinpoint exactly those figures, then we'll be able to determine what would be the correct value to put there.
So instead of larger, we're gonna replace our optimal signal to noise ratio. But once we do our research and find out what would be a good signal to noise ratio, we would then update that information.
Yeah, I mean, it would be good to put an actual number.
Yeah.
But then again, what does distortion ratio mean? What does that mean?
That's the whole term: signal to noise and distortion ratio.
Well, noise and distortion go together. Okay. All right. So yeah, typically people just say signal to noise ratio.
When I was looking it up, that's what it is. There was one that was signal to noise ratio, and there was another one I saw that was signal to noise and distortion ratio. So I just figured this was a little bit more compared to what we were looking for because we were talking about distortion specifically, but we can determine which one we want to use.
Yeah, but I mean, it's a subtle difference. I mean, it's abbreviated SNR. You'll see SNR. You won't see SN/DR. So noise is anything that's not in the original signal. So it may be distortion, it may be random noise. I think whoever worded it like that probably just wanted to distinguish between external noise or atmospheric noise or something, as opposed to frequency distortion or something like that, or attenuation, so on and so forth. But anything that changes your signal from what it was originally is considered noise. Okay, I would like to see something in here about, and I think you had before something about the number of the devices that it could, or the number. How do we word it? It should allow at least multiplexing of at least so many devices, so many different channels, or something like that. So I think it was in there before, where I think originally I said 10, we went down to 4. So I would like to see that in there, as well as I think some of those. User friendly, okay. You got it's allowed to understand within 5 minutes instead of time 7 devices. Less than 2 minutes. All right, we'll just discuss that offline. But I think we need to go back and at least add something about the capacity of the system. All right, there's the number of users or the number of different channels.
All right. So this is level 0 block diagram of our wireless audio distribution system. Right now we just have our inputs we have 4 audio select lines that are to use as an audio input for the channel selectors. We also have stereo audio select lines that are the input stereo channels. Outputted out of our system are 4 wireless audio connections that represent data being sent to each individual output peripheral independently. We also have LED lights that indicate which channels have been selected. We have control systems that allow each output audio peripheral to choose which input source to receive media from. Okay, we're going deeper, level 1 block diagram. And we have 3 systems. We have the audio selection unit, we have the audio broadcast unit, and then the PLS, which is our personal listening system.
All right.
Okay. Okay. So for our audio selection unit, we have the 4-channel selects used to select the 4 input stereo channels. We also have the 4 input stereo channels to input the audio. Output it out of our ASU, we have 2 standard stereo outputs, and we also have the 4 LEDs to display the channel selection. Part of our audio broadcast unit, we have the 2 standard stereo inputs coming in from the ASU, and we're outputting 2 wireless stereo inputs into that will be received from our PLS. Inputted from our PLS, the personal listening system, we have 2 wireless stereo inputs per PLS device, and we also have 10 control lines corresponding to the 10 personal listening devices used to determine which of the received audio signal will be output. We also have 10 audio outputs corresponding to all devices, and it's going to be determined by the user. So this is the level 2 of our audio selection unit. We have the stereo mono mixer circuit, then we also have the channel mux system and our LED array. So we're going to go deeper into the stereo mono mixer circuit. We have 4 input stereo channels to input our audio. Outputted, we're going to have 4 tethered left and right stereo outputs, and also 4 tethered mixed mono outputs. We're going to go to the channel multiplexer system, which 4 channel selects used to select which of the 4 inputs for stereo we'll be using. We also have 4 tethered left and right stereo audio input signals, and also 4 tethered mixed mono input signals. And for our LED array, we just have 4 channels used to select which of the 4 stereo channels input audio, and correspondingly, we have the lights that would represent which of those channels has been selected by the user.
Okay.
So for our level 2, this is our level 2 block diagram of our personal listening system. So within the personal listening system that Kadeem spoke about before, we go a little deeper to show you how the audio is received wirelessly from the audio broadcast unit and how we actually get it output to our audio device. So we have different blocks: our receiver block, analog mixer selector, the main selector, the UTMF decoder, and the phone, which is actually our VIVA selector app. So to talk about each block, the receiver within the PLS system actually received the wireless audio from the audio broadcast unit, and it also it allows us to receive a select line from the main selector as input, so that we can choose whether it's mono or stereo audio on those lines, and then it outputs 2 stereo lines that are selected from that receiver.
Okay, well, I'm thinking about that's what I meant to say. Where you have in your requirements about communicating with 2 Bluetooth speakers or something, 2 types of Bluetooth devices. Yeah, I don't think that's needed anymore. Yeah, because what we're doing is not specific to Bluetooth. So go ahead. I'm sorry.
To talk more about the analog mixer selector. In the analog mixer selector, we have the 2 stereo inputs that came from the receiver block, and then these lines may contain either 3 or 4 mono signals, or even 2 stereo signals. And then we also have the binary selects, which allow us to select one of those 4 audio lines to be outputted. The audio out comes straight from the analog mixer selector, and then the audio out, that's just the audio that is outputted to the speakers.
Okay.
And the main selector, so the main selector is the block that actually interacts with the two previous blocks, the receiver block and the analog mixer selector block. So the main selector allows us to get the user's input of which channel they wanted to listen to and actually communicate that to the receiver block and the analog mixer selector block. The DTMF decoder actually decodes our information that comes from the phone application. So we have a phone application that allows you to select a particular channel and it sends a DTMF signal. The DTMF decoder block decodes that signal and transfers that information to the main selector so that we can get that information to the rest of the blocks. And the VIVA selector application, this is where you actually input the user control. So basically the user presses a button based on what channel they want to listen to, and then it sends that information in a DTMF signal to the DTMF decoder block,
Okay.
as I've explained before.
All right. Let's pause it. Can you pause it?
You can't pause it, stop, and then you have to.
You stop it. Okay, go ahead. Stop it.